if I consider first element in my row 1, that must be greater than remaining 2 element. That means after performing summation, I must have to get the larger number. When I substitute these values and whatever the values I'm going to get, that is my x3. Here x value is nothing but present x value, and this z value is nothing but previous iteration z value. Hello to all, a warm welcome to my new session on solving simultaneous linear equation. I am your Revati ma'am from the Department of Computer Science, Vidyashram, First Grade College, the Temple of Excellence, Mysuru. So dear student, once again in my today's session, I am going to deal with how to solve linear equation. In that, I am going to deal with Gauss-Seidel method. Before going to start my today's session, let me to recall the topic what I have discussed in my last session of this unit. So dear student, in my last session, I started with Gauss elimination method and some example problems. In the Gauss elimination method, whatever the linear equation we have, that is represented in the form of augmented matrix. For example, think that I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in my Gauss elimination method, I just want to make this element 0, this element 0 and this element 0. And I want to find the solution for 3 unknowns. So, this is the Gauss elimination method, and I have discussed and I solved some example problem. So, dear student, in my today's session, I am going to deal with Gauss-Seidel method. In this, we are going to discuss how to apply Gauss-Seidel method in order to find the result or solution for the 3 unknowns. Along with that, I am going to discuss some solved example. Now, dear student, let's see how this Gauss-Seidel method is going to work. So, dear student, we have some linear equation. See, this is my linear equation. Now, what I want to do, I just want to check that in my equation, all the elements are diagonally dominated or not. And if I consider this element and this element, okay, this is treated as diagonal element, and I must have diagonally dominated element. For that, I want to consider this condition. So here, A11 is nothing but my first element of row 1. And if I consider A22, so that is nothing but the second element of row 2. And if I consider A33, that is nothing but the third element of row 3. Now, see here, if I consider first element in my row 1, that must be greater than remaining 2 element. That means after performing summation, I must have to get the larger number. And if I consider A22, so it must be larger than A21 plus A23. And if I consider third one, that must be larger than A31 plus A32. Now, dear student, now I am going to write that system of equation in the form of x1 equal to A11. That means I am going to take this one outside. So, I have variable x1, okay, then it is 1 divided by 11, and when I take A11 outside, I have B1, then I am going to write remaining elements as it is. So, B1 minus A12 x2 minus a13 x3. Now if I consider next unknown, that is x2, then 1 divided by 22 b2 minus a21 x1 minus a23 x3. And if I consider third one, see, I have third unknown, that is x3, that is equal to 1 divided by a33, that is b3 minus a31 x1 minus a32 x2. And now let me to write the simple example to illustrate Gauss-Seidel method. Think that I have 15x 2y, then 3z equal to 15. Then I have 3x plus 15y plus 10z, which is equal to 20. Then I have 4x plus 5y plus 15z equal to 40. So this is my linear equation. And see here, if I consider first one, second one and third one, okay, all these are 15x, 15y and 15z. That is nothing but these elements are diagonally dominated. So these elements are diagonally dominated. And if it is diagonally dominated, what I want to do? I just want to check if 15 greater than 2 plus 3. It is true. Now if I consider second one, 15 greater than 3 plus 10. So it is also true. And if I consider 15 which is greater than 4 plus 5, it is 9. So it is true. So 15 is greater than 9. If this condition is true, then what I want to do? I just want to find the x value. So to find the x value, what I have, that is x equal to, I'm going to bring this 15x outside. So x equal to 1 by 15. Then I'm going to bring this b1 here. So I'll write 15 minus 2y plus 3z. So this is for first equation. And if I consider second equation, y equal to, I have 1 by 15, then 20, that is b2 minus 3x minus 10z. Now if I consider z, 1 by 15, then it is b3 40 minus 4x minus 5y. Okay, like this I'm going to construct the equation. And I'm going to start my iteration. So initially, to start my iteration, what I want to do, I'm going to substitute some value. That is nothing but x1 equal to 0, x2 equal to 0, x3 equal to 0. And here x1, x2 and x3, 3 are the unknowns. Now see here, what I'm going to do, I'm going to substitute the values. In my first iteration, it is x1 equal to 1 divided by 11, b1 minus a12 into 0, because my y is 0 and z is 0. Okay, and when I simplify this one, I'll get b1 divided by a11. Now, for the next one, I want to find out x2. For the x2, it is b2 minus x minus z. Okay, so what is x here? That is nothing but b1 divided by a1. And if I multiply this one by 0, I'll get 0. So here 1 divided by a22 of b2 minus a21 of b1 divided by a11. And if I consider third one, see here, this is my b3 minus x minus 1. So, instead of substituting x equal to 0 and y equal to 0, what I am going to do? I am going to consider the previous value, this one and this one. And I am going to substitute here. Okay, and when I substitute these values and whatever the values I am going to get, that is my x3, and this is the completion of first iteration. And if I want to perform second iteration, for the second iteration, whatever the x1, x2 and x3 values I got in my first iteration, that is the input to the next iteration, and it is going to continue until and unless I am going to get the approximate solution. So, dear student, this is all about Gauss-Seidel method. And why I am going to have Gauss-Seidel method? In order to find the approximate solution for the three unknowns. Now, let me to explain simple program here. So, dear student, I have my first program under Gauss-Seidel method, that is, solve the following system of equation by Gauss-Seidel method. And this is my equation, and this is my linear equation, in the sense I don't have any power factor. Okay, so dear student, I just want to check if these equations are diagonally dominated or not, and I want to cross check the condition. So what is the condition? The first element must be greater than the summation of remaining element. So here if I consider 10, 10 is greater than 2. Okay, and if I consider next one, 10 is greater than 2. And if I consider third equation, once again 10 is greater than 2. Okay, fine. Now check. I have 10x, I have 10y and I have 10z. So this equation is diagonally dominated. See, I have 10x, I have 10y and I have 10z, and it is nothing but the diagonally dominated. Now, the given system of equations are diagonally dominant and the equations are put in the form. So, it is diagonally dominated. So, what I am going to do? I am going to rewrite this equation in the form. So, what I want to do? I just want to take this 10x outside. So, I'll take 10x outside. That is nothing but x equal to 1 divided by 10. That is nothing but 12 minus y minus z. Okay, this is for my first equation. And if I consider second one, I just want to take 10y outside. So, y equal to 1 divided by 10, and I am going to write the remaining elements as it is. That is 12 minus x minus z. Okay, fine. Now, if I consider third equation, I just want to take 10z outside. So, z equal to 1 by 10. Now, 12 minus x minus y. So, 12 minus x minus y. Now, I want to start my iteration because I want to find the approximate solution. So, here in my first iteration, I have 1 by 10 of 12. That is nothing but B1 minus, see, my x is outside, so I want to consider y minus z. So, what is y? That is 0 and z is 0. Okay, and when I divide this one, I will get the answer that is 1.2. So I'll get the answer 1.2. Now see here, I have y1. Okay, now 1 divided by 10 and 12 minus, I have the answer 1.2, and what is my z? That is 0, and I'll get 1.08. Now if I consider z1, 1 divided by 10, it is 12 minus my x is 1.2. Okay, my x is 1.2 and my y is 1.08. So I'll substitute and I am going to get the answer 0.972. Okay, now in my next iteration, what is my x value? That is 1.2 and y is 1.08 and z is 0.972. Okay, fine. Now, in my second iteration, see, this is my y and this is my z. Okay, fine. And here it is b2 minus x minus z. And here it is b3 minus x minus y. Okay, fine. Now I'm going to substitute x value as well as z value. And when I calculate x2, that is, I'll get 0.9948. And in my y, for a y, see here, I'm going to consider this x. Okay, now, and if I want to consider this one, I'm going to consider my previous z value. And what is my previous z value? That is nothing but 0.972. And when I calculate y of 2, I'm going to get the answer 1.00332. And if I consider z, see here, this is my x, okay, and this is my y now. Now, when I substitute the value and when I calculate z of 2, I'm going to get 1.00188. And these three x, y, z values are the input to the next iteration. So, in my next iteration, see here, it is b1, okay, then minus y minus z because I'm going to find x. Now here it is b2 minus x minus z. Here it is b3 minus x minus y. Okay, fine. Now I have previous x value, y value and z value. And for this equation, I required only y and z, and I'm going to substitute y and z, and I'm going to calculate x of 3, that is 0.99965. And if I consider x of 3, then see, I have b2 and I'm going to substitute the x value. Here x value is nothing but present x value and this z value is nothing but previous iteration z value, and I'm going to find y. Now dear student, if I want to find z of 3, I'm going to consider present iteration x value and y value, and when I substitute, I'm going to get the z of 3 value, that is 1.00003. Now if I consider fourth iteration, for the fourth iteration, which x value, y value and z value I want to consider, that is nothing but the previous x value, y value and z value I want to consider. Now, this is my b1 minus y minus z. Here it is b2 minus x minus z. And here it is b3 minus x minus y. See here, x is outside and what are the remaining two unknowns? y and z. Here y is outside and what is remaining? X and z. And here z is outside and what is remaining? X and y. Now for this x of 4, I am going to consider previous iteration y value and z value, and when I substitute I am going to get the answer 0.99995, which is approximate to 1, that is which is nearer to 1. So I can write 1. Now if I consider y of 4, okay, for this one, I'm going to consider this x value, that is 1, and I'm going to have the previous z value. So what is previous z value? That is 1.00003. Okay, and when I substitute these values, I'm going to get x of 4, that is 1.999997, which is approximate to 1. So I can able to consider 1. Now, if I consider z of 4, I want to consider x and y. Okay, now see, I got x is 1, I got y is 1. And when I substitute, I'm going to get the answer 1. Now, this is the approximate solution. Okay, now if I consider previous iteration value and present iteration value, okay, I'm going to get the same value. And further, if I continue my process, then what's going to happen? I'm going to get same values. So no need to continue the iteration further. And I'm going to stop the iteration. Now, what is my x value? X is 1, y is 1, and z is 1. So, dear student, here Gauss-Seidel method is mainly used to find the values of 3 unknowns, and whatever the value I'm going to get, that is approximate value. Now, in my next session, once again, I'm going to deal with Gauss-Seidel methods. In the sense, I'm going to discuss few more solved example under this method. Anyway, dear student, let's meet in the next session with the more information about Gauss-Seidel method. Until that, keep watching and keep learning. Thank you.